We present a novel image classification technique for detecting multiple objects in a single image. In addition to image classifiers, we apply spatial relationships among the so-called subobjects to verify and to predict locations of detected and undetected subobjects respectively. This approach is applied in the context of Phone Guide, an adaptive museum guidance system for camera-equipped mobile phones. Phone Guide utilizes the visitor's personal mobile devices for information retrieval and allows identifying individual exhibits by simply taking a single photo of them. The classification process can be separated into two steps. In the first step, a user takes a photograph of a scene that contains an arbitrary number of objects. The mobile front-end application of Phone Guide carries out a local image classification, and the result is presented as a probability-sorted objects list. It contains all possible candidates, beginning with the most likely candidate on the left side. The correct object can be selected with a minimum number of clicks, and corresponding multimedia information is presented. However, if a group of subobjects was captured rather than a single exhibit, the user acknowledges the scene classification in the objects list to start the consecutive subobject classification. The detected subobjects resulting from this second classification step are labeled in the captured photograph. The user can select the desired subobject, and the corresponding multimedia content is finally presented. For supporting the identification of multiple exhibits, each subobject has to be considered during the initial training phase. After a video of a scene with subobjects was recorded, a bounding box for each subobject is manually defined in the first frame. For each frame in the video, the subobjects are tracked via mean-shift tracking, and subimages, non-subobject subimages, and spatial relationships are extracted. Finally, global color features of all the subimages are computed to train the three-layer neural networks. After an image was captured, the subobject detection searches for the first anchor subobject by varying the mask size. The search masks are spirally shifted around the center of the image until one subobject is identified through image classification. A neighborhood search is performed next to refine the location of the anchor subobject until the final position is found. Based on the location of the first subobject, the spatial relationships can be applied to find the second exhibit. The detection is performed equally to the first subobject. If enough anchor subobjects are detected, the spatial relationships span intersection planes, which define reliable search areas of the remaining subobjects. This is repeated until all subobjects are detected. From each subobject's center, a line is drawn to the representative thumbnail arranged below the image. The user can browse through the probability-sorted objects list and select the desired exhibit. The corresponding multimedia presentation is then presented. By predicting the locations of undetected subobjects, our approach outperforms related brute force methods. By applying the spatial relationships among the detected subobjects, even completely occluded exhibits can be found where image-based classifiers would fail.